Continuing with where we were in the last lesson, I'm going to go into the ecosystem material and make just a few changes to the scale, starting with the long grass. Bring that down to 0.06 and maybe bring up the small grass field plants to 0.16. I'm going to go into the density and reduce the density amount. And I'm also going to turn and check on variable density. We can right click and edit the function, or you can control click on the preview to open the function editor. And I'm just going to connect the density output to the same noise that's creating the distribution. Now, typically using the same function would cause an issue with the lower parts of the fractal, what we see in the preview as the dark spots, because those are being used to create the lower instances or objects within the ecosystem population, or whatever I guess would be on the top of the list, but the presence is the lower number. So if the density is also that dark output, basically -1, it means no density. So those objects wouldn't be showing. But what we can do is, even though we're connected to the same scale noise, we do have an independent scale for the density. So what we can do, and since we're in a world mapping mode, what I can do is take the Z, or the up and down axis, and scale that down to 0.3, and that way they don't completely overlap. There is going to be a bit more variation to it. And then the fractal can run somewhat separately, but still kind of intermingled. We can also go into the other X and Y axes. And I'll go ahead and set 0.8 on the X and 1.25 on the Y. Another thing that we can do to modify the density output is to modify this filter here. What we can do, if you double click, it'll open up the filter browser, and you can go through and select filters from here. You can also right click and save filters if you create your own. If you right click, go to edit filter, it'll open up. You can also control click on it to open the editor. At least in the standalone, some of the shortcuts may not work within the host application. You can double click to add points and then move them to modify the filter, and then we can also populate or hit preview if you're working with dynamic population to see the results while you still have the filter open. So what we can do is basically clip out, in this case, the lower portions and just allow the very high values in the noise to show through. We could also go to the upper right button here, and we could swap. So if you left click, it'll flip the vertical axis, and right clicking the horizontal. We could also turn on curves in the upper left, and the curves are going to go outside of the filter in this case. And what we can also do is go down to the bottom here and turn off the show filtered defined domain only to see what happens to the numbers before and after negative. Before -1 and after 1, which can sometimes create some very interesting effects. In this case, it would overramp the density. I'll go ahead and click OK, and then go back to the filter, right click and reset it. Go back to edit filter, and I'm just going to turn on curves, and that'll manipulate it quite a bit. Actually, we'll go ahead, add a point to the center, and just what you can do is grab little handles to rotate them on the sides, and just kind of move that over a bit. Now what we can also do within the filter is there's an Influence Environment tab on the bottom. So if we want to make this filter only apply to certain areas, so if we collect, or if we go ahead and click on dependent of slope, now the filter is dependent on slope and the surface normal of the terrain. So that's kind of cool, a way to kind of ease it in and out. We could also do the same thing with orientation. And the direction around the terrain, and altitude as well. I'm going to go ahead and leave these options off for now. Actually, I will go ahead and maybe leave on a little bit of slope. So next we're going to go back into the ecosystem material. And we're going to add another ecosystem layer. What we can do is select the topmost material layer that's not an ecosystem layer, and select ecosystem, which will add a new layer. And we'll go ahead and rename that, just call it Areas Eco. And we're going to add some items, some plants to the list. And I'm just going to use some of the native plants because I believe these multicolored ones are only available on Cornucopia. And I'm also going to go into grasses and plants, and we'll add a small grass field plant. So now if we go ahead and populate it, and be able to see our scale here. Now what I want to do is use the layer from below it to influence this one. First thing I'm going to do is I'm going to move over to a different camera. I'm also going to go into the ecosystem with the grass, the first layer, and increase the scale a little bit, just the overall scale of all of the plants. Make them just a little bit larger. I'll do I'll just type in 1.6. And now if we go to the new eco, and I'm going to rename this flower eco, and we'll call the other one grass eco. Under the general tab, there is in the distribution options, there is an affinity and repulsion from layer. Affinity allows us to populate close to the objects below it. And sort of clump around. We can also invert that if you go below 0 in order to fall off into the space where there are no instances. Affinity is a fall off, more of a gradient fall off, and repulsion. If we go ahead and increase repulsion, they're basically inverse in the way they work, at least which way the direction of the slider goes. So now we're populating in areas where there are no instances in the layer below, but the repulsion makes the fall off very sharp. So now if we want to populate near the other objects, we can just reverse the repulsion, but instead of falling off at a gradient or variable density, it's much harsher. And we can also use the two together to influence each other. And I am going to go ahead and just reduce the size of the body clump. Go over to scaling, orientation. Let's change the maximum size variation to 0.3. We can increase our density. Just adjust the affinity and repulsion a bit. And I'm going to change the size of the colorful bodies as well. Some of those are a little larger than I want. I am going to increase the overall scaling, maybe to 0.6. A little more variation. Actually, maybe we'll go ahead and bring it up to 1.6. And go into the small grass field plant and increase its size a little bit. Maybe not that much. 0.13. And then increase the presence to 2. Maybe 3. And I'm going to go ahead and add another ecosystem layer. And move it up to the top with the arrows. And I'm going to add in the dry weeds and the patch of grass. And we're going to set that to an affinity with the layer below. I'm going to need to adjust the scale. Unless it's just the preview that's off, which might be. I'll go ahead and set that to full quality so we can view that a little better. And dry weeds need to come down in size quite a lot. And try 0.01. So we'll try 0.03 for the dry weeds, and we'll do 0.05 for the patch of grass. And change back our shading mode. The dry grass populates or attaches to the surface well above the geometry for the model. A lot of it does go underneath, so only really the top part's used. Might even need to adjust the scaling 0.02, just bring it down a bit. And then I'm going to go into the density, increase that. And what I want to do is go to the color, use a variable color. We can right click and edit the color map and change that color to something a little lighter and desaturated. And that should make it look a little more dead. You can ignore the strange colors that will show up in the overall color here for the color correction. The color from the color map is being used and then overlaid with the variable color. And what you'll see is almost a negative in some cases with the overall color. Sometimes they'll show up purple and all different colors blue, and, but that's not going to change the instance color to that, or what's showing here. It's just kind of the opposite that's being used to kind of apply a sort of color subtraction. And I think I might desaturate that color a little bit more, maybe lighten it up a little further. And we'll call this dry grass eco. Oh. And then I'm going to go back to the steep areas, add one more ecosystem layer. And we're going to add the patch of grass and small grass field plant. Adjust the affinity, and I know the patch of grass has to be reduced in size. Increase the small grass field plant 0.2, so patch of grass 0.05, small grass field plant 0.2, See how that looks. And we'll reduce the affinity a little. Should I go ahead and bring it into negative? And then increase density just a little. And that should be enough to cover just about everything. And I am going to go ahead and adjust my previews. Because I'm recording, my system's starting to hang a little bit with the shaded billboards. We'll just set the grass to not display at all. And I have decided to make just a few changes to the ecosystem. I am going to take that top grass eco and change the overall scaling. Adjust the presence of the small grass field plant to 2. And then go to the dry grass eco and change the presence of the dry weeds to, let's say, 6. And reduce the patch of grass to 0.02. Now, because we don't have any painted instances as part of this ecosystem, one thing we could do is switch it over to a dynamic population. So what this will do is populate everything just within or in front of the camera, anything that's needed. So it also includes if you have a reflective object that's reflecting surrounding ecosystems, those will be included as well. So what we can do is I'm just going to go through and clear these out first, just to refresh the OpenGL. Sometimes it won't clear itself out. It happens occasionally. And then I'm going to switch this over, or each of the layers, to dynamic population. Then we can then select the topmost layer in the main material and go to Preview, which will populate every single layer that's an ecosystem within that material. If we take a look in the top view, what we're going to see is that just outside the camera is what's being populated. And if we were to move the camera or make any changes to the ecosystem, we would then need to update the preview. Or if you render, it'll automatically generate the population at that point of the render. So during the animation, it'll go through and populate only what's around the camera, which means with the dynamic population, you can also animate several different features. Pretty much the main features within the material editor are all something that can be edited and animated, keyframed over time. Now the next thing I want to do is change one of the materials of the ecosystem. If we open up the material summary, we're only going to see the primary materials within the scene. The one called material is just my ground plane, because I have reset it. The Sahara rock for the rocks, and then the grassville eco that's on the terrain. If we go over to the materials tab on the right, and this is part of the browser, we'll find every material that's part of an ecosystem, and also the rest of the materials in the scene. if you take a look, it is sorted standard materials, and then we've got plant materials. So if you have any vegetation that is not an instance, that will show up there. Materials from imported objects, whether or not there's clouds in the scenes. And then we've got ecosystems, where we'll show the ecosystem layers, and then the ecosystem materials. And I'm going to go down to what's called ST petals. I also want to note, if you go down to the lower right, there is a button you can click on. If you click and drag up or down, it will change the size of these previews. You can double click to open the material. And I'm going to change the overall color of this, edit the color, and make it a bit more purple. Now, because the background of this image is white and not the same color as the petals, the overall color is very light because it's taking into account that white when it creates the overall color. So we don't want to use a really intense color out of this. We don't want to use a dark color because we do have to keep in mind that that is being included. I think I had it better the first time. I'll just go ahead and modify that a little. Maybe lighten that up. And increase our saturation. That's a fairly bright purple. Go ahead and darken it up. I just went ahead and reset that. I'm going to do it again. I'm going to go ahead and just adjust the color first, and then just bring down the lightness on the right just a tiny bit. And then you can just kind of nudge that down until you get the color you're looking for. So I'll just go with that. Click OK, and then what it'll usually do is update previews depending on where you edited the material. So because every material is accessible through the ecosystem, you could load in additional plants and just swap out materials. It makes for a lighter weight scene if you just stick with the kind of the stock plants and then modify the materials after the ecosystem is created, because you don't have to generate additional plant species. And that way you can avoid additional cache files and memory being used in the scene. However, the limitation is that if you modify the material of the object and you want to use it more than once with different materials, you really can't. Well, there are special ways to set up material distributions through ecosystems. We're not going to be covering that because there just isn't enough time. But if you have two of the same species loaded in, doesn't matter how many material layers, if you want to change the material, it's going to change every material on every instance or usage of that vegetation within the scene, with the exception that you can change the overall color per ecosystem layer, or paint and color instances that way. I also want to note, if we go back to the material editor, you'll find that the paint button is cleared out when you have dynamic population. The reason for this is anything you paint, it will just be deleted once the population occurs. So if we go ahead and go to the flower eco, and I'm going to turn off dynamic population and populate it. What we can do is activate the paint, and then we can use the painter to either add single instances or brush. Right now I have it set to restrict to underlying objects, so it only will paint on the terrain, but I can turn that off. I also want to note that it is a bit more responsive in the other viewports, top viewport, side viewport. The perspective view does tend to be the laggiest. But if we go through the list, what we can see is we have the entire population that we do normally. If we go down to the bottom, we can see we have a selection to paint what? A bit of everything, so it'll choose from the list randomly, or only the selected item. So that way we could just pick one specific plant, and I can go in and add those. And we'll take a closer look at the painter a little bit later, different lesson, or later in the lesson. But now we have those painted instances. Go ahead and we can see those in the main viewport. But if we select to populate, it's going to remove them completely. As you can see, it deleted them because it does not store painted ecosystems and material layers. And now, because I edited that, I'm going to go to the topmost layer and reset up the preview for that. So if you want to keep it, or anything you've painted, it's a good idea to keep it on the global ecosystem, which you can open the xStream painter if you're within the host application, or just click on the ecosystem painter button, and that's a separate ecosystem. Because the rocks in the scene don't have an ecosystem on them, and they're really not going to be a major part of the scene, and also because I am saving the scenes incrementally, the rocks themselves have a lot of polygons, and many more than are probably needed for at least this stage of the scene. We can always take these rocks and load them back in, but what I want to do is we're going to decimate them, save them out as VOB object files. So we're going to select both objects, and we're going to go ahead and group them together. We can use the group object command, or in the interface over here on the left, we can group them. Go ahead and I'm going to right click and save the object. And I've just called this foreground rock. And when you go to save an object, you get the ability to create a preview picture of the object. So you can navigate within this to render a picture. You can hold down the control key and right click in order to zoom in, right click to rotate that around, and you'll find all of the shortcuts available for that in the options. If you go to File, Options, Operations, and scroll all the way down, and you'll see the triggers and editors and small previews, and there you'll have all of the operations available within that little preview. So when you go to load the object in through the browser, it'll show that preview. So now what we can do, since we have that saved out, we're going to edit the object, and we can select Decimate. I just right click to open the edit object. If you're working xStream through host application, you can go to the object menu that's in the xStream menu. Edit object, pull up the polygon mesh options. We're going to select Decimate, and now we can choose the level of decimation, so how much of a reduction in quality and polygon level do we want. And I'm going to go ahead and move the slider to around 40% or so. And then we can just click OK, and then it'll take a little while to process, but it'll go ahead and break down the polygon count. So we've gone from a little over 700,000, it was almost 800,000 polygons, down to 70,000. And because most of the detail comes from the material, in this case It's not that much of a loss of quality. Even in the main camera view, there's enough polygons to be able to render that pretty good with the materials that are on it. So I could either keep it like that, or what we can do is replace this later with the object we saved out. If we go back to the polygon mesh options by editing the object, we can also control the smoothing angle, or the falling angle, the point in which the polygons kind of round out and we no longer see the polygons. If you want to see sharp facets on the rock, anything like that, you can reduce the smoothing angle. Let's go ahead and bring it down to 33 degrees. And now we'll start to see the kind of holes showing up in some of the polygons where the points are being kind of pinched inward. I kind of like the little holes. They add a bit of depth to the rock. If you encounter any problems like light leaks or any problems with shadows, especially if you're running radiosity calculations or anything like that, global illumination, then I might need to smooth it out. But otherwise, we can keep it at a lower angle. So if we take a look at the file sizes now, originally with just basically the rocks in the scene and a simple ecosystem, we had about 161 megs, or actually 157 megs, since kilobyte is not exact, and then still a little more of a complex ecosystem, 341 megs, and then switching it over to dynamic population for the ecosystem, we got down to 70 megs, and just saving out that object, the size of the scene is now 15 megs, or yeah, 15.4 megs. This is important because when you're working with more complex scenes and as they get bigger, Vue is also, or has the option to save backups and also autosave. So in the options and general preferences, you can choose whether or not to enable backups. So .back files, it's going to be just a copy of the scene as a backup, so in case something happens to the other file, maybe it gets corrupted in the memory, then you have a backup there. And then autosaving, and I've got mine set to every 5 minutes with 10 max autosaves. What's cool about this is we can create manual snapshots. So I just created a snapshot, and if you go to File and Revert, we can revert to different snapshots. And if the file is saved, then you'll see a list of autosaves if that's enabled. And then you can go back to, in this case, every 5 minutes, I should have a save. So the more complex the scene, the longer it takes to save, and it ties up system resources, and the scene can become less responsive. When the time comes to render the scene, and if we need a higher quality rock surface and we want to load that object back in, what we can use is the replace by commands. You can right click with the object selected, and we can choose replace by fit object, and then we can load the object in, the saved one. If you want to go a step further in reduction of scene complexity while you're working on other areas of the scene, you could also replace it, let's say, with a cube. Or a sphere if you're trying to keep the fall off of the ecosystem something you can preview. So now we have that replaced, and that would reduce the scene complexity by quite a bit if you continue to do that with other objects. So then if we want to bring that back, place by fit object, and we're going to load the object in. And now the full resolution object is back. And in case you didn't catch how I brought up that other panel, down in the lower part of the browser here, there's an arrow to browse the files. So that way you can just use your regular system browser to go through files. And since I just saved this object, that's the quickest way to get to the same directory because it will remember the object directory. And rather than using the undo operation, what I can do to get back to the previous files is I can revert to snapshot and go back to that snapshot that I saved earlier. And now we have the downsized version back. It's also a good idea at this point to purge the memory, which will remove any undo operations that are stored in the memory that contain the higher resolution object. There's another feature I want to show you within the polygon mesh options. So we're going to select the foreground rock, the decimated rock, edit the object, and in the polygon mesh options towards the bottom you'll find a Turbosmooth mesh subdivision section. What we can use are a couple of different subdivision methods. In this case, because Vue uses triangles to build most of its objects, the Catmull-Clark quad mode for 4-point polygons won't work, but we can use the loop triangle method, and this will just smooth the mesh. And this dialog is just saying that it's going to apply it to both objects. So we could also increase that level beyond 1 to subdivide further. To see the polygons of this, I'm going to select the object and go up to the Aspect tab and change this over to a wireframe. With this other button, we can change the display mode. And then we can see the wireframe quality. And go ahead and I can turn off the Turbosmooth. And then we'll see the original object. Now another thing we could do is use the turbo smoothing, but use a different mode and change it to dynamic. What this will do is subdivide the mesh depending on how close the camera is to it. So the closer we zoom in, the more subdivisions are applied. These are great ways to minimize the amount of polygons being used for actual meshes. Vue handles polygons really well when it comes to procedural terrains and ecosystems and working with instances, but working with the scenes that have real mesh objects like this, most of the polygon counts you would normally have for an ecosystem would just overload Vue and make it incredibly difficult to work with. So I'm just going to go back now and turn that to the loop triangle mode. And if you're having display issues, you can also use non-smooth versions for the previews. So it would use the lower resolution mesh for the OpenGL. And then we go ahead and turn that back to smooth shaded mode. So we see the decimated preview, but when it renders, it'll use the turbo smooth option. Keeping in mind that it's really a balance between file sizes and memory usage while rendering